In today's lesson, we're going to continue talking about slope, but we're going to focus on slope as a rate of change. So our learning target today is given a contextual situation, I can find a rate of change. So contextual situation meaning a real life situation like story problem, I can find a rate of change. So when we're talking about slope yesterday, I'm going to write down here below here, the slope, we used a lowercase letter m to represent slope. We talked about slope was the change in the y's over the change in x. Okay, the change in y over change in x. In other words, it was the change in the dependent variable over the change in the independent variable. And we talked about this in a lot of different ways. So it's always the change in the dependent variable over the independent variable. So when we were talking about tables, change in y over change in x, we were looking at how that was changing. When we looked at a graph, we talked about it being the rise over the run. And then when we were given 2 points, we used this concept of change in y and change in x in the table to come up with the formula y2 minus y1 over x2 minus x1. Today when we're talking about this, we want to make sure we understand that in a contextual situation, when we talk about the change in the dependent variable, we are always talking about the final, meaning the ending, minus the initial, or the beginning. So the final or the end minus the initial, meaning the start or the beginning. So please take a note of that. That will be important for us to reason through some of these key parts of slope. So now today we're talking about slope as a rate of change. In words, we're going to say a rate of change specifically that compares the change in the dependent variable, and remember we said dependent variable are the y values typically, to the change in the independent variable. So the change in the dependent variable to the change in the independent variable. And these are the ratios we were talking about yesterday. So now let's take a look at this. Example 1 says the table shows the cost of using a computer at an internet cafe for a given amount of time. Find the rate of change. So rate of change, anytime I see that, I'm thinking, okay, that means slope in cost with respect to time. So cost with respect to time. So before we even dig into the problem, let's think about what this actually means. A lot of you guys might have internet on your phone, or we have access to internet all the time. But in other countries, and especially 10, 15, 20 years ago, people didn't have cell phones that they just had the internet at their fingertips all the time. So I remember when I studied abroad in Honduras, in order to use the internet, I'd have to go to an internet cafe. So this is what they're talking about, an internet cafe, which is basically, it was like a store or a coffee shop, because you could sometimes buy food and stuff there, where you would pay a certain amount of money to sit at the computer and use their internet, because everyone didn't just have it on their phones or accessible to them wherever they went. So that's what this is talking about. Now when I look at this, I want the rate of change, so I'm saying slope. And when we do slope, we're going to talk about a ratio of two things. Now the way this is set up is the rate of change in cost with respect to time. So I have to think through, what is the dependent variable, which one is independent? Well, I'm thinking, does the cost depend on how much time I use, or does the time I use depend on how much, what the cost is going to be? And in this case, the cost is the dependent variable, and the time is the independent. So what I want you to do is pause this video right now and think back. We have this table. How did we use the table yesterday to find the rate of change? Go ahead and do that right now as you pause the video. Now that you've paused the video and you've tried this on your own, let's talk through this. So in a table, I see here I'm adding 7, and for time, I'm adding 2. So the cost, well, here's my cost. The rate of change in cost with respect to time, that's 7 over 2. Now, we can think of this a couple different ways. You can just leave it as 7 over 2 because that is a simplified fraction. If we do that, though, we want to make sure that we have units. So let's think about cost. What are the units on cost, and what are the units on time? Or what are the units on 7, what are the units on 2? Take a second, try and think through that on your own. When we look here, we see the cost, or the units on cost are dollars, so this would be $7 over. Units on time are hours, so $7 over 2 hours. So let's try and interpret what that means. So the thing is, $7 over 2 hours. Well, in the context of the problem, what this means is it costs $7 to use the computer for 2 hours. So $7 every 2 hours, and that's how we get these different values here. Now, if I wanted to, I could figure out what that would be as a decimal. 7 divided by 2 is 3.5. Now let's think about what the units. It's still dollars over hours, or another way to say that is dollars per hour. So that fraction bar also means per. So anytime I see that, you could think of this as a per. So $7 per 2 hours, or $3.5 per hour. Now I'm not going to write 3.5 because if I'm using dollars, it makes sense to talk about pennies. So $3.50 per hour. So you could interpret it like this, or you could say it costs $3.50 per hour to use the computer. You can interpret this rate in 2 different ways. Either one of these would be a correct answer, but you have to remember to have units on your answer. So let's make a little note here. Don't forget units. Very, very important for all of these problems when we're using the context. All right, scooching down here. Example 2, go ahead and read through this on your own. Underline important information. Now that you've read it on your own, then let's look through this together. Bought a candle for my grandma for her birthday. Cost me that much, okay? When she first lit the candle, so when she first lit it, it was 7 inches tall. After burning it for 3 hours, it was only 4 inches tall. And I want to find the rate of change. So remember, anytime you see rate of change, you're thinking slope. The height of the candle with respect to time. So, thinking about candles. When you burn a candle, the candle melts and it goes shrinks. So that's what it's asking us to find. What is that rate? How fast is it melting is really what it's asking us to find. It used the words, the rate of change with the height of the candle with respect to time. So when we set that up, that's going to be the change in height over change in time. All right, pause the video and on your own right now, try and think through what would the change in height be over the change in time. And don't forget, try and include units. So take a minute and do this on your own right now. All right, now that you've tried this on your own, I'm going to talk through a couple different ways to think through this. One, we can make a table. A lot of people like tables because it helps to organize. So we have our time and we have our height. Okay, so time, what are we talking about? It looks like we're talking about hours, so I'm going to say time in hours. And the height was originally 7 inches, now 4 inches, so the height's going to be in inches. So the time, well, at first, it was 7 inches tall. Okay, so the height would be 7. Well, what time do we associate with at the beginning? Well, before any time's passed, we'll say that's time is 0. So you could make it 0 and 7. If you wanted to, you could write that as an ordered pair, 0, 7. That's another way to think through this. After burning for 3 hours, so now 3 hours has gone by, it was only 4 inches tall now because it melted, right? It's shorter. Okay, so we could have, after 3 hours, the height is 4. In other words, you could think of that as 3, 4, if you wanted to think of it as a point. So what we can do in the table, if you haven't done so already, find the rate of change. Go ahead and find that rate of change in the table. When I do that, I see to go from 7 to 4, I'm subtracting 3. The height is going down by 3. And the time increased by 3. So when I find my rate, I have the change in the height over the change in the time. Well, if we simplify this, this would simplify to -1. Now, let's think about what this means. Why is this negative? What the heck does that mean? Well, when we look at it, it goes from 7 inches tall to 4 inches tall. So the height went down or decreased by 3 inches. So let's look at the units here. Height is measured in inches, so we'll have -3 inches per 3 hours. Units on time are hours. So if we simplify this here, it would be -1 inch per hour. So when we interpret what this means, the rate is negative. So the rate is negative because the height is decreasing. So we're going to have a negative rate when the height is decreasing. So let's go back up here and add this to our summary up here. When we talk about a rate of change, when the rate of change is positive, that means we have an increasing function. So let's picture what that is. When we were interpreting graphs increasing, we were rising from left to right. But when the slope is negative, that means we'll have a decreasing value, or that. So I'm going to bubble that in. So when slope is positive, the dependent variable is increasing. When slope is negative, it would be decreasing. So that's going to be important. So the fact that the height is decreasing means that we have to have a negative slope. Now, you could have done this a different way if you like to use the points here. You could have said that the slope, if that is equal to y2 minus y1 over x2 minus x1, or in other words, 7 minus 4 over, you got to make sure that 0 stays with the 7, so 0 minus, in this case, the 3 goes with the 4. So you would have 7 minus 4 is 3, 0 minus negative, or minus 3 is -3. Notice we didn't have the -3 on top, but that's okay. We would get -1 here. All right. If we switch the order around, if we did the final minus initial, like we talked about, this being the final, this being the initial, then you would have 4 minus 7 over 3 minus 0. That will give you the -3 over +3, which is still the -1, but now we have the -3 on top and the 3 on the bottom. So if you follow the final minus initial, you would have the same values as you did with the table. Either way, they all simplify to be -1. So the final answer would be -1, and we have to have units. We can either write inches per hour or inches per hour like that, and that would be that. So what this, how we would interpret this is that the height of the candle decreases, that negative means it decreases by 1 inch every hour. That would be the interpretation. All right, let's flip to the back and try the next one. All right, so as we look at here, excuse me, it's saying a community theater performed a play each Saturday evening for 10 consecutive weeks. Consecutive meaning in a row. So 10 weeks in a row, they performed this play. The graph shows the attendance for the performances in weeks 1, 4, 6, and 10. So attendance meaning how many people showed up. So describe the rates of change in attendance with respect to time. So rates of change, again, we're thinking slope, in attendance with respect to time. Meaning we're going to be talking about the change in attendance with respect to the change in time. All right, so we have 3 different chunks we're really looking at. We have from week 1 to 4. We have, actually, let me use green here. So from week 1 to 4, we'll do in green. From week 4 to 6 in blue. And then week 6 to 10 in red. All right, so we have these 3 sections we're looking at. When we look at the green one, I want you to be thinking through, is the attendance increasing, decreasing, or staying the same over those weeks? And what about the blue and the pink? So go ahead and kind of think through this right now. Try and process what's really going on. What's happening to the attendance? Now that you've kind of thought through this, let's think about this. Well, This right here is increasing, so I'm thinking, well, should that slope be positive or negative? Well, if we're increasing, this will have a positive slope. Here, this blue is going down, not a whole lot, but it is decreasing, so this will be a negative slope. And this pink is going down, it's going actually down at a greater rate. So that is a negative slope as well. So when we think about that, what that means is the attendance, meaning the number of people that go, started off lower in the first week, but then more and more people came. But then once we hit the 4th week, we started having less people come. And even fewer people started coming between weeks 6 and 10 until it hit its lowest amount. So we like to often do rise over run when we see a graph. So let's just first focus on from week 1 to week 4. If we first think rise over run, the slope being rise over run, when I look at this, let's count it. To go from here to here, it looks like I go up, well, about 1, 2, I'm in the middle, so it looks like about 2, and I run 1, 2, 3. For sure that's 3. So about 2 over 3. But when I say 2, let's look at these units. This is really going from, well, if that's 0, that's 100. This is 50, and this would be 150. So we're in the middle of 100 and 150 to the middle of 200 and 250. So 2 units here. Each unit represents 50, which means we're really talking about 100 people. So about 100 over 3. And if we think about units, the change in attendance, well, attendance means people. So this is 100 people over 3 weeks. Now, this is not exact. We're doing approximate because we weren't sure exactly where it went. So the more accurate way to do this one would say y2 minus y1 over x2 minus x1. So if we look at these points, we would have 232 minus 124 over 4 minus 1. And when we do that, now we see we have 108 over 3. So 108 people over 3 weeks. This is more accurate. So this was approximate. I'm going to cross that out. We want to be looking at more accurate so we can actually use the 2 points. Excuse me. All right, so what that means is 108 people, 108 more people came over these 3 weeks. So the attendance increased by 108 people in the 3 weeks. So that would be the interpretation. The attendance increased by 108 people over 3 weeks. But if I simplify that, that's really 36. So if we think about that, that's 36 people per week. That would be the correct simplification. So this is one interpretation, but simplifying it, we would say that the attendance increased by 36 people each week or every week. So instead of saying the whole time, we could say each one of these sections, 36 more people, 36 more people, 36 more people. All right, so this was the one in green. That was that first from week 1 to week 4. What I want you guys to do right now is to figure out the rate of change for the pink and the blue sections, so week 4 to 6 and then week 6 to 10. And I want you to write this sentence, interpret what this means. So pause the video right now and go ahead and do this on your own. Now that you've done it on your own, let's take a look and check your work with mine. So we already discussed week 1 to 4, we said it has a positive slope. If we go from week 4 to 6 and we use the 2 points, we get negative 28 over 2. So the attendance decreased by 28 people over the 2 weeks, or negative 14 people per week. And that negative, remember, when it's negative, it means it decreased. So the interpretation would be from week 4 to week 6, the attendance decreased by 14 people each week. And the slope is still negative for this pink section. We had negative 132 over 4. So from week 6 to week 10, we decreased by 132 people over those 4 weeks, which means it simplifies to we decreased by 33 people every week, and that would be the interpretation. All right, so we have one more problem that we would like to go over. Talking about Pebbles and Bam Bam. Go ahead and read through this and underline the key information. You can pause the video to take some time to do that. Now that you've read through this, let's talk about it together. Pebbles and Bam Bam are riding in the car to the mall. So they're going to the mall. They left the Flintstones house at 9:45 a.m. and they arrived at 10:30. So this is when they started. This is when they ended. If they lived 5 miles from the mall, how fast were they going? Well, when we're talking about how fast, let's think about how we measure how fast. Remember, how fast is a rate? So we know we're going to have something over something else. Now, when you think about how fast you're driving to school, or the bus is driving to school, or your parents are driving to school, or whoever, when we're driving a car, our cars measure in miles per hour, mph. Well, miles per hour, we know that's really miles per hour. So let's think about this. Miles is a measure of what? Well, miles measures a distance. So this is really change in distance over hours is a measure of time. So change in distance over change in time. So we're looking at the situation and thinking, how is the distance changing with respect to time? Go ahead and pause the video and try and figure this one out on your own right now. Now that you've thought through this on your own, let's think through this together. The change in the distance, well, they drove 5 miles. To go from their house to the mall was 5 miles. And the change in time, well, at 9:45 they started, they ended at 10:30. So we're thinking, how much time has passed? Well, from 9:45 to 10 o'clock, that's 15 minutes. And then 10 to 10:30 is 30. So you got 15 minutes to get you to 10, 30 minutes to get you to 10:30. That would be 45 minutes. So we have 5 miles over 45 minutes. If you simplified that fraction, that would be 1/9. So 1 mile per 9 minutes. And how we would interpret that, that could be one answer. That every 9 minutes, they drove 1 mile. If you punch that in a calculator, you get that that's approximately 0.111 repeating, so we could point 111 like that. You could still say mile per minute. But now the interpretation would be slightly different. What this is saying is that every minute they drove about 0.111 miles. So we're kind of changing the interpretation here. Now, we can think through this in a different way. Instead of doing it just like this, we could have made a table, and you could have the time and the, what is this, distance. So before they leave their house, they've traveled no distance, and that time, it said, was 9:45. At 10:30, they arrived at the mall 5 miles away. So they increased by 5 miles. This time increased by 45 minutes. So you could think of it in a table as well. If we don't want to think about it in minutes, we could think hours. So I'll do a little side note. You could have 5 miles. If we like miles per hour, we have to think about how many hours it is. So on your own, think through. How many hours is 45 minutes? So 45 minutes, if I divide that by 60 minutes in an hour, gives me that would be 3/4 of an hour, or 0.75 hours. So if I do 0.75 hours, now I can have the answer in miles per hour. So we went 5 miles in 0.75 hours, so 5 divided by 0.75. That means we would go 6.666 repeating miles per hour. So this would be approximately 6.67 miles per hour. So if you want to do miles per hour, you'd have to do your units like this. All right. So these are rates of change or slope in a story problem. Your homework tonight is going to be practicing more with slope.